All right, so like we just talked about, guys, we've been dealing with equations. Today, we're going to look at system of equations. Okay? So a couple things that I want to point out here, guys. When we're dealing with systems of equations, with words that end in S, what does that mean to y'all? Multiples. Okay? So that's going to be very similar to what we're dealing with. Okay? So when you see equations with an S on it, we're probably going to be dealing with more than one. Okay? So that's going to lead us into what is systems of equations. Now, systems of equations are, it is two or more equations with the same variables. Okay? Two or more equations with the same variables. Okay? Now, please be careful. I'm going to give you an example right here, but this is just an example. So please, when you put this in your notes, please put this is an example. Okay? Now, if we're looking at this, let's just say, for example, we have y equals 6x plus 2. And then we also have y equals 5x minus 1. Okay, so we got y equals 6x plus 2 and y equals 5x minus 1. Okay, how many equations do we have there? It's not a trick question. 2, right? Okay, looking at the first equation, what are my two variables in that first equation? Y and x. Not a trick question either, right? All right, what are my what are my variables in the second equation? Y and x. So this potentially is a system of equations. Okay, 1, how many equations do we have? 2. So that fits the first part. Okay, and then they have the same variables, y and x, so that fits the second part. Okay? So, knowing that, we're going to move on, guys, and we're going to look at the solution to a system. Okay? So a solution to a system. So there's two ways to have a solution. What's another word for solution? Answer. Okay? So we're going to do this graphically. If it's graphically, what do you think you're going to have to do? Graph it. Algebraically, don't say we're going to do it by algebra. What do you think we're going to have to do? We're going to have to solve equations. Okay? All right, so the first thing that we're looking at, it says the point x and y where two lines intersect. Okay? Now, you guys probably know what intersect is if you had geometry with me or your other teachers last year. It's one of the first things that we covered. But what's another a synonym for intersect? Meet or cross. So if you guys want to put that in parentheses, it's where they cross / meet. Okay? Now, algebraically, guys, this is the point x and y, or your coordinate, or your ordered pair, okay, that makes both equations true. Okay? So, it makes both equations true. So where you take your value for x and you take your value for y and you substitute those in, it gives you a true answer. Now, for some of you that are unfamiliar with a true answer, what is 6 plus 2? 8. So if you have 6 plus 2 equals 8, that equation is true. If you had 6 plus 2 equals 9, that equation would be false. So it's as simple as it sounds. Okay? Now we're going to look at types of solutions. Okay? The three types of solutions that we're going to look at are intersecting lines, parallel lines, and same line. Okay? So I'm just going to use my drawing tool here. Okay, so intersecting lines, guys, are actually lines that do what? Cross or intersect. Okay, and they're going to intersect at a point. And that point is right there that I just put where they intersect. Okay? Now, if lines are intersecting, they have one solution. One solution. What that means is there'll be one x value, and there will be one y value. That's the place where they intersect. Those two equations only have one solution where they will meet or they will intersect, and it will be at the point of intersecting. Okay, it will be the point where they intersect on that coordinate plane. Okay, now the next one that we're looking at, again, I'm going to use my line tool, are parallel lines. Okay, and what are parallel lines? Lines that never meet, never cross, never intersect. Okay, it's kind of elementary, but the best example of parallel lines are railroad tracks. I know you've seen them. I know what they look like. They run parallel side by side. Those two rails will never cross or intersect. Okay, now they may intersect with another set of tracks, but that single set of tracks, each rail will never cross or never intersect. Okay, now if that happens, for that, there will be no solution. And the symbol for no solution, guys, it is a circle. Okay, and then it has a slash through it. Okay, so basically that is no solution. And I know, putting it in real world terms, guys, you have seen the signs where it says no parking, no smoking, and it's got the P or the cigarette in it, and you just slash right through it. Okay, so that's what that symbol is. Okay, now the next one that we're going to look at, guys, is same line. So you have two equations that graph the same line. Now the first one, I'm just going to use blue. It's been good about showing up and what you guys see. So for the same line, guys, I simply just want you to draw a nice straight blue line right there. Okay, now I'm going to come back with another color. I'm going to use green. And when you draw this same line, guys, I want you to start a little short of the top and graph all the way down and leave a little bit at the bottom. And now for mine, I'm going to leave a little bit of blue just so you can kind of see both lines. But those two lines are right on top of each other. Okay? And what that is you have two equations that graph the same line. They're going to be graphed right on top of one another. Okay? So what that means is, regardless of what you put in for x and y, you will always have an infinite solution. Okay? They will be the same no matter what. Okay? So do you guys know what the infinity symbol is? It is the forever sign. Yes, that's what infinity is. It's that forever sign, or whatever you guys call it. Okay? So if putting it in simple terms, it almost kind of looks like a sideways 8, but it's like Maggie said, it's that forever sign, intersecting, continuous, that travel, okay? Never ending, okay? So after looking at those types of solutions, guys, we're going to be solving these systems or these equations, and we're going to solve them by graphing. So guess what you're actually going to have to do? You're going to graph. Okay, so there's 3 steps to this, and I'm going to give you the 3 steps that make it really easy. Okay, some of them you're going to get to skip, some of them you're going to have to do. Okay, so the first step, guys, is rewrite the equations in slope intercept form. Okay, rewrite the equations in slope intercept form. Now, some of those equations may already be in slope intercept form, so you get to go ahead and check that off and skip that step. Okay, step 2 is graph the lines. So for each equation, you'll graph a line for that equation. The second or third equation, you'll graph a line for that one. Okay, and then number 3 is very simple. After you graph them, you identify the solutions. Okay, you identify the solution. So, if they're intersecting, it's one solution. If they're parallel, no solution. If it's the same line, it's infinite solution. Okay? So, with that being said, guys, we're going to look at number 1 real quick. All right, so number 1, guys, we have y equals x minus 8. Okay, so we're just going to graph this. we'll start with my y-intercept like we normally do. And my y-intercept is what? And y-intercept is what? -8. So we'll come down here. Each of these coordinate planes is based off of 10. So each unit is 1. There's 10 units on this coordinate plane. So that's 10, 9, and 8. And I'm going to place it right there, down at the bottom. Okay? Now, my slope, is that a positive slope or a negative slope? Positive slope, so we need to be traveling up. It needs to be an uptrend in that direction. Okay? So up 1 over how many? 1. Up 1, over 1, up 1, over 1, up 1, over 1. Now, what I'm about to share with you guys is not a math rule. It's not anything that anybody came up with that you have to follow. This is just what I do. My suggestion is when you're graphing these system of equations, I would plot 5 points if possible. Okay? So I would try to put 5 points. You may have to go back and add more if needed. I feel like all the ones that I've dealt with, 5 is the best amount. 3 could come up too short sometimes, so I feel like 5 is a good number. Okay? All right, so we graphed the first one. I'm going to use my line tool. I'm going to connect those. I think red and green's been showing up really good on the board today, so that's what we're going to use. Okay? All right, any questions about that right there? We good? All right, now we're just going to come back and we're going to graph the second one. All right, so we have y equals -2x plus 1. Okay? So, we're going to graph y-intercept, which is positive what? 1. Okay? Graph the slope. My slope is negative. It's a downtrend from my y-intercept. So we're going to go down how many? 1, 2, and over how many? 1. Down 1, 2, over 1, down 1, 2, over 1, 1, 2, over 1. Use my line tool and connect those. All right, so we put 5 points. We plotted 5 coordinates there on that line. So it was in slope-intercept form. We graphed the lines. Now step number 3 is what? Identify the solution. So looking back, look at those lines right there. Are they intersecting? Are they parallel? Or are they the same line? Intersecting. So now if they're intersecting, we've got to find the solution at the point where they intersect. So the point where they intersect is we traveled on my x-axis how many? 1, 2, 3. So this ordered pair is going to be 3, comma. And how many did we travel down? 1, 2, 3, 4, -5. All right, so number 4, guys, it's going to be very similar to the other ones, except now we've got one of the equations that we have to put into slope-intercept form. Okay, the second equation's already there. The first one, we've got x plus 2y equals 4. Okay, so putting this into slope-intercept form, you guys know we've got to figure out what y equals. So simply, you guys know that's minus x and minus x. Okay, my suggestion would be if you have some scratch pad, it's probably going to be a lot easier for you to do this that way than having to use your drawing tool. Okay, so removing the x, okay, putting it on the other side of the equation, we now have 2y equals a -x plus 4. Okay, getting the variable by itself, isolating it, you guys know we got to divide by 2, and then the whole other side of the equation by 2 as well. You know those 2's will cancel, and then we're left with y equals. Now, we can't divide x or 1x by 2, okay, and get a whole number, so we're going to leave that. That's essentially -1/2 x. You guys agree with that? Okay, plus 4. Okay? Now we're going to graph this one, and we're going to go back and graph the second equation. Okay? All right, so let's quickly graph this equation. So, all right, let's go back real quick and make a correction. 4 divided by 2 should be, that's bad, 2.